my channel Simple Concepts by DJ. Today we will be discussing about an important concept called as voltage divider rule. Okay, this is voltage divider rule, or it is called as VDR. The acronym of voltage divider, this is VDR. The abbreviation of VDR is, voltage divider rule is VDR. Okay, so here I'll draw the circuit diagram. Circuit diagram is, it will be like this. We have three resistors. Three resistors are connected in series. Not three resistors, it might be n number of resistors. Just for the purpose of explaining, I'm considering three resistors over here. And these three resistors are connected with a DC supply. They are connected with a DC supply. Let us assume that the supply voltage is V volts. Okay. So here this one is the resistance. Let us assume that R1 is the resistance in ohms, R2 be the value of the resistance for the second resistor, and R3 be the value of the resistance for the third resistor. So you have three different values for these three different kind of resistors. See, all these resistors are being connected in series connection with the supply voltage. So the supply voltage is, the magnitude of the supply voltage is V. Okay. So this is the setup. So when the circuit is closed, a current I happens to flow inside the circuit. A current I happen to flow inside the circuit. So the current will be same. As far as a series circuit is concerned, the current will be same, but the voltage will be different. Okay. So when this voltage source is switched on, a current I keeps flowing inside the circuit. The value of the current will be same. So when this current happens to pass through the resistor R1, automatically you will be encountering a voltage. A voltage V1 happens to develop across the resistor. Okay, so a voltage V1 will develop across a resistor, because for expressing a voltage you need to say voltage is developed across a resistor. For expressing or for explaining about the current, the nature of the current, you need to say that the current passes through the resistor. For current you need to use the word through, and for voltage you need to use the word across. Okay, so here a voltage is developed across the resistor, which is named as V1. Similarly, here if you connect a voltmeter over here, another voltage V2 is developed across the resistor R2. Similarly, if you connect another voltage, a voltmeter over here, you will be getting V3 as the voltmeter reading when it is connected across the resistance R3. So here from this circuit, this is a series connection. As I told, in a series connection, the current will be same. The magnitude of the current will be same when the current starts from the point positive terminal of the battery and it ends in the negative terminal of the battery. From plus to minus, when the current keeps moving, the value or the magnitude of the current will not change. It remains constant. But as far as a voltage is concerned, see, for each, and if you have three different values for voltage, but here the value of current is same. Here, when you connect this voltmeter across the resistance R1, you are getting V1. When you connect the same voltmeter across the resistance R2, you are getting a different value for this voltage. Similarly, for R3, you are getting a different value of voltage. So that is V3. So the voltmeter is subjected to different kinds of voltage measurements when it is connected across three different type of resistances. Okay. So now, what we need to do is, I'm interested to find the value of voltage V1 that is being developed across R1. So it is very difficult. You cannot find it. So you need to apply this voltage divider rule. Okay, if you want to find this V1 means, you need to use this voltage divider rule. Similarly, you can find value for this V2. You can also find this value for V3. Like this, if you have n number of resistors, just for the purpose of explaining, I have given three resistors. There can be any amount of resistors, R1, R2, R3 up to Rn. You can connect it in series, and if you keep this experiment like this, and if you connect them with a voltage source, you will have V power n up to V power n number of voltages will be developed in a series connection, right? So now I'm interested to find the value of V1. So for this, I know V1. What is V1? V1 is nothing but I as per Ohm's law. As per Ohm's law, V1 is equal to I into this R1. I into R1, right? So the current I passes through the resistance R1. When it is passing through the resistance R1, the voltage, the Ohm's law is nothing but the product of current into resistance. So this I is the current and R1 is the resistance. So V1, this V1 is nothing but I into R1. So but we know that V equal to I into R. See, for this entire circuit, what will be the total resistance? R total. Let us assume the total resistance of this entire circuit be denoted by R total. R total is nothing but R1 plus R2 plus R3. So this is nothing but the total resistance. If I sum up all the resistor values, that is called as the total value of the resistance in this circuit. Right. So R total is nothing but R1 plus R2 plus R3. Right. So if I take Ohm's law for this entire circuit, not only for this one, if I consider the entire circuit, Ohm's law will be capital V equal to I is the current, I into R. What is R? R is nothing but R total. It will be R total. This is Ohm's law for the entire circuit, and this is Ohm's law for this particular circuit, this particular part of the circuit under consideration. Okay, so if I take this for the entire circuit, it will be V equal to I into R total. So what is I over here? I can be written as V divided by R total. I can write it as V divided by R total. So I got the value of I. I is nothing but the current that is circulating or moving in through the entire circulating through the entire circuit. I got the value, the magnitude of the current for this entire circuit is I is nothing but V divided by R total. Okay, so I'm going to substitute this value. I'm going to substitute this value here. So if I substitute this value over here, I'll be getting V by R total. V divided by R total into R1. So V divided by R total is I into R1. So this is the value, that is V1. V1 is nothing but V divided by R total into R1. So this I can also write it as V1 equal to R1 by R total, R1 divided by R total, R1 divided by R total into V. I'm just rearranging the terms, okay, changing the terms. R1 by R total into V. So this is V1. This is the value of V1. For getting the value of V1, this is the formula that I need to use. So V1 is nothing but R1. R1 is the value of the resistance over here. We know the resistance value divided by R total. So we know the resistance of all the resistors that has been connected in series in the circuit. So you need to total all the resistance. If you sum up all the resistance, you will be getting the value of R total. Then into V. V is nothing but the supply voltage. Supply voltage is V volts. So that also you know. So multiply this ratio into this supply voltage V. If you do it, means you will be able to get the value of this individual voltage V1. Similarly, for finding the value of V2, V2 can be written as V2 is equal to V2 is a voltage that is being applied across, that is developed across the resistance R2. V2 is not developing across R3 or R1. It is developing across the resistance R2. So V2, for this V2 is equal to, you need to take R2. Here in the first case, you have taken the first resistor value. In the second case, you need to take the second resistor value. So V2 is equal to R2 divided by R total. R total remains the same. There won't be any change for R total into V is the supply voltage. There also won't be any change in the supply voltage. So into V. So this is V. So similarly, you found out the value of the individual voltage, that is V2, which is developed across the resistor R2. So V2 is nothing but R2 divided by the total resistance R total into the supply voltage V. So you got V2. Similarly, you can also find V3. V3 will be this V3 will be R3 divided by R total into the supply voltage V. So using this formula, using these three formulas, I found the value of different values, different values of voltages that has been developed across the various resistors. Okay, so these are the V1, V2, V3 are the voltmeter readings when it is connected across different resistances. So this is called as voltage divider rule, or it is called as VDR. Okay, so this is very important, especially for people, for students who are appearing for IIT entrance, JEE mains and all. This kind of question will usually they will ask. So at that time it will be very difficult to recollect it. So try working out all these kind of derivations. You will be able to get used to these kind of formulas. So once you get these numerical problems of this type, you will be able to deal with it more effectively, and you will be able to get the result correctly. Okay, so this is all about this video. Thanks for watching my video. Thank you.